Good morning. Welcome and thank you for joining this webinar on the Energy Technology Perspectives 2017 and the need to accelerate energy efficiency. And it's a webinar that will focus particularly on the building sector. This webinar complements very well our previous webinar on the roadmap for building energy codes and standards in Mexico. The webinar today is based on a publication produced by the International Energy Agency called the Energy Technology Perspectives 2017, which is available on our website in English. There's an executive summary also available for free in Spanish. The webinar is organized by the International Energy Agency with the kind support of the Secretaría de Energía, SENER. My name is David Morgado, and I'll be moderating the webinar. And I'm joined by my colleagues John Dulac and Thibault Abergel from the IEA's Energy Demand Technology Unit, and they'll be carrying out this presentation. You can see the team members there. So before we start, I'll just go through the agenda for today. So we'll have some introduction and just explanation on how the webinar works. And then we'll have welcome remarks from Santiago Crujeras, a Director General for Energy Efficiency and Sustainable Energy at SENER. And then Thibault and John will be talking about the global status of energy and technologies, the status of buildings worldwide and in Mexico, looking at the energy technology strategies across the world, but focusing particularly again in Mexico. Finally, a pathway towards sustainable buildings, and then we'll have a Q&A at the end. We would really like to hear from you and would like to include your voice in the conversation, so please ask questions and share comments so that we can discuss these at the end of the webinar. To do so, before we start the webinar, we would like to go through the setup of the webinar and let you know how you can participate in today's session. The slide shows an example of the attendee interface. You should see something that looks like this on your computer. You have joined today's webinar listening through your computer speaker system by default. This means if you usually can hear music on your computer, you'll be able to hear the presentation. If you'd like to call in using the telephone, just locate your audio pane and select Use Telephone. The dial-in information and access code will then be displayed. The number and access code are indicated on this slide here at the bottom. You also have the ability to ask questions using the questions pane. Simply type in your question either in English or Spanish and click Send. At the end of the presentation, we will have time for discussion, and we'll go through the questions submitted during the presentation. Please note that we'll be recording the webinar. We will make a link available for those that have missed the webinar, as well as if you want to share it with colleagues or would like to go over it again. For those that usually attend our webinars, today we'll be introducing a new item to the webinar to allow for greater interaction. We will launch a quick poll or quiz that's similar to a quick questionnaire during the webinar to allow us to get your views on certain aspects of the presentation and the information presented. There'll be one quick poll during the webinar, and you'll be asked to select one answer from 3 options. The results will be immediate, and we can briefly discuss and share them during the presentation. So unless there's any questions at the time, if not, we'll proceed with introduction speech by Santiago Crujeras, Director General of Energy Efficiency and Sustainable Energy at SENER. Just give me a second to put him online. Anna, can you hear us? Santiago, are you there?
Yes.
Hi, Santiago, we can hear you. Good morning.
Hi, good morning. Can you hear me?
Yes.
Okay, hi, good morning. I'm Santiago Crujeras, Director General for Energy Efficiency and Sustainability. On behalf of the Ministry of Energy of Mexico, SENER, I would like to thank the International Energy Agency for this new webinar on the energy technology perspectives. It's a great pleasure to welcome all of you. I would like to thank David Morgado for helping us organizing this webinar. as well as John Dulac and Thibaut Abergel for joining us this morning and telling us a little bit more about the energy technology perspectives. If you allow me, I'm going to continue in Spanish to welcome the audience in Mexico. Muy buenos días a todos. En nombre de la Secretaría de Energía, me da mucho gusto darles la más cordial bienvenida a este webinar sobre las perspectivas tecnológicas de energía, coorganizado con la Agencia Internacional de Energía. Como ustedes saben, México se encuentra en un proceso de adhesión con la Agencia Internacional de Energía, en el cual hace un par de semanas México ha sido aceptado por la Agencia Internacional de Energía para adherirse como el país miembro número 30. Estamos ahora en el proceso de ratificación de esta decisión por parte de las autoridades legislativas de nuestro país y nos da mucho gusto tener la oportunidad de tener estos webinars que nos han dado una visión mucho más amplia del sector energético con el apoyo de la Agencia Internacional de Energía, dando a conocer y acercando las publicaciones que esta agencia realiza y produce y que ha compartido con México y con toda la audiencia de México, y que a través de estos webinars se ha podido tener un alcance no solamente hacia personas interesadas en el sector energético en nuestro país, sino también hacia personas que se encuentran en otras partes del mundo y que han aprovechado esta oportunidad que hemos estado ofreciendo conjuntamente la Agencia Internacional de Energía y la Secretaría de Energía de México. Sin más, agradezco a John Dulac, a Thibaut Abergel y a David Morgado, quienes nos acompañan esta mañana por parte de la agencia, así como a todo el equipo que nos ha permitido organizar este tipo de webinars y que de alguna manera nos ofrecen oportunidades de alcance mucho más sólidas y más fuertes para nuestro país en materia de energía. La eficiencia energética, como ustedes saben, ha sido una de las áreas que han participado como pioneras en este proceso de adhesión, diseñando pues nuevas políticas, nuevos canales, nuevos puentes de comunicación. Y bueno, que inicialmente empezó a concebirse como un área de oportunidad, hemos podido comprobar a través de estos poco más de 2 años el número de personas que asisten. Hoy en día tenemos casi 200 personas participando en este webinar de diversas partes del país, de diversas partes del mundo, y nos da mucho gusto poder potenciar esta herramienta que nos ofrece el alcance de estas publicaciones, el alcance de los expertos de la Agencia Internacional de Energía para compartir lo que se está haciendo y lo que se está desarrollando para el mundo y específicamente para México. Sin más, David, Thibaut y John, muchísimas gracias por esta oportunidad y el piso es de ustedes, como dicen en inglés, the floor is yours. Muchísimas gracias. Que tengan buen día.
Muchas gracias, Santiago.
Muchas gracias, señor. Thank you, Santiago. Thanks for all your support in organizing these webinars. We've done a total of, this will be the 17th webinar we've organized so far. We've been able to reach more than 2,600 people, which has been great, and we thank you for all your support. Without further ado, I'll pass on to my colleagues who will be talking about the Energy Technology Perspectives 2017.
Thanks very much, David. My name is Thibaut Abergel, and I'm here with John Dulac, the IEA Buildings Team Lead. We are working on the IEA Buildings Energy Model, making estimates of the energy consumed by IEA member countries and looking in particular at low carbon trajectories. The main question we are trying to answer is how technology opportunities and policy instruments in the building sector could contribute to the international efforts of curbing greenhouse gas emissions. Historically, the IEA explored technology paths for the transition to sustainable buildings. For this year's publication of ETP, Energy Technology Perspectives, the buildings team has examined how we could possibly accelerate this transition. As Mexico is modeled separately, we will present first the Global Building Status Report in Mexico, then the energy technology strategies needed to be on the route for sustainable buildings. Finally, the policies that we think can help to be on this path, and then their effects in terms of cutting greenhouse gases emissions. But first, we'll take a step back to put things into context. So here are two graphs showing first the total primary energy supply on the left, and the energy-related CO2 emissions on the right. And the first thing that is striking is that these trends have historically gone upwards, especially in non-OECD countries since 2000. The second thing is that energy-related CO2 emissions are not decoupled with the total energy consumed. And the third thing is that there has been a decrease in the CO2 emissions in 2008, but this was due to the global economic recession. The official data stopped at 2014, but we are quite confident in arguing that emissions flattened since then. So in 2016, it is very likely that emissions remain stable for the third year in a row without being associated with an economic downturn. As you can see, that's the first time in history that we've seen this decoupling between economic growth and carbon emissions. Now, whether plateauing emissions would be the new normal or an anecdotal fact, we need to decrease energy-related CO2 emissions to meet the climate mitigation goals. So plateauing is not enough. We need to reach net zero emissions in our low carbon scenarios by 2100 or even by before 2060 in our more ambitious scenarios in the beyond 2 degrees scenarios. So the IEA has identified 3 scenarios: the RTS, the reference technology scenarios, which is our baseline. It is not a business as usual scenario. It is more ambitious than a business as usual scenario because it already includes the commitment by all countries in the world to reduce, to cut down greenhouse gas emissions. Then we have the 2 degree scenarios that aim at limiting the rise of global temperatures below 2 degrees, and the beyond 2 degree scenario that aims at going beyond. And what we see is that the contribution of buildings is quite significant because we will need to go from the RTS to the 2DS to reduce the total emissions by 90 gigatons. The share of buildings seems to be smaller than for industry and transport, but from a systemic point of view, it might not be the case because, as you may know, 55% of the energy consumed in buildings, 55% of the electricity is consumed by buildings. So the power sector emissions can indirectly be attributed to buildings. And you know that buildings are getting more and more electrified, so a lot of emissions resulting from power generation can indirectly be attributed for buildings. So cutting down the energy consumption in buildings is critical to make climate mitigation goals because it will support the decarbonization of the power sector and allow electrification of other sectors such as transport, which will need electric vehicles and then which will consume more energy. So with this in mind, we will make the Global Building Status Report on Mexico. And we will use the poll. I have one question for you. So the question is, do you think that Mexico is on track to meet climate mitigation goals? So I think you have 30 seconds to answer, if it's correct. So you can use the button to vote. If you think that Mexico is on track to meet the energy efficiency goals, to reduce greenhouse gas emissions, reduce the final demand, you can click yes. If you think that it's not on track, you can click no. And if you have no idea or you think that it's globally performing well, you can press maybe. I don't know how many seconds you have left to vote. 2 seconds. Okay, so 2 seconds left?
No.
No. Sorry.
About 30 seconds left.
30 seconds left. Okay, it's 1 minute.
And,
So it looks like very split. A third of you think that they're on track, they are not on track, and a third of you are not sure. And the answer is in tracking clean energy progress. So it's an excerpt of the ECP publication that highlights that the building sector is underperforming. So buildings are not on track to meet climate mitigation goals. Generally. The immediate action that countries can take is to put forward commitments for low carbon and energy efficient buildings to implement their NDCs. It's a first step to send a clear signal to scale up actions across the global building sectors. Now we've looked at two specific subsectors within the building envelopes, the lighting, appliances and equipment. And the building envelope have shown quite some positive developments, but not enough to be on track. So these developments need to be scaled up, and countries have to adopt mandatory building energy codes to improve the energy intensities by 30% by 2025 to be on track with our 2DS scenario. 30% by 2025. For lighting appliances and equipment, it's slightly better, thanks to improvements in LEDs, for example, that LED sensors have gone up. We're going to see this later. The recent legal agreement is a great opportunity for cooling equipment markets as well to move to high efficiency products. So we've seen some positive improvements, but we have still a long way to go. Here is a graph about the building energy intensity per square meter and the building energy use worldwide since 1990. And we see that there is no decoupling between floor area growth and energy consumption. So building energy intensity reduction, the circles in purple, are far below floor area growth. So intensity reduction is the reduction of energy consumption per square meter. And the diamonds in gray show the growth in terms of square meters. So unless the intensity reduction reaches the level of floor area growth, we won't see any decrease in total energy consumption. So global building energy intensity per square meter improved historically at roughly 1.5% per year, and we recommend that this number should reach 3% per year to meet the climate mitigation goals. Now if we go to Mexico, we see that the picture is quite the same, that intensity improvement remains somewhat a bit shy until since 1990, but that floor area grew very much. And a very positive note, after 2000, we see that energy intensity started to decrease because the purple circles are going up. Nonetheless, they are not catching up with rising floor area here. On another positive note, we see that the additional energy consumed was made by electricity and not fossil fuels, such as oil. That the share of oil is slightly declining and that all the additional energy is actually electricity. So this is a good news because electricity is a good means to drive high efficiency technologies in the building sector, but we will need to accelerate this transition if we want to be on track for the 2DS. Now, this graph is a decomposition of Mexican energy demand in buildings with regards to 5 influences pulling up or driving down total final consumption. So population growth in blue, less people per dwelling, larger dwelling surfaces, and other activity effects here, they all resulted in increasing the energy use per square meter and have contributed to increase total final consumption by nearly 900 petajoules here. And yet, energy efficiency on the bottom only offsets a third of those 900 petajoules. That is approximately 300, a bit more than 300 petajoules. So the net result of this is that total final energy here, the black diamond, has gone up, resulting in 7 exajoules of cumulative energy demand growth since 1990. So just as an order of magnitude, 7 exajoules is 5 times the energy consumed by Mexican buildings in 2014. So we've added 5 times the energy consumed by buildings in a year, in 25 years. So now if we want to make strategic actions, we must target the end users that are experiencing the most significant growth. As we can see, the growth in Mexico mainly results from growth in space cooling, in green, from lighting and appliances. So we need to focus on these three end users if we want to be the most impactful, because these are where energy use is going to go up, has gone up historically, and will continue to go up in the near future. Here is the result of our scenarios. So I remind you that the RTS means reference technology scenario. It's our baseline. And we see that total energy consumption, if we are continuing our trends, meeting our current commitments, but not doing anything more, that we are going to add a significant amount of energy, like more than 1 exajoule by 2060. What we also see is the increasing share of electrification. As I told you, it's very important because the power sector is not decarbonized for the moment. It will be in our scenarios, but we're not there yet. So it's important to emphasize the importance of energy efficiency to reduce the constraints on the power sector. Now, if we want to move to the 2DS, we see that this energy efficiency has been scaled up because the total energy intensity in terms of energy consumed per person decreased significantly between the RTS and the 2DS. And the net effect is to decrease the total energy use. Now, if we want to go even beyond this commitment, as pledged under the Paris Agreement, we need to move away from fossil fuels. The shift away from fossil fuels has already begun to the 2DS. You see that the share of oil is decreasing, but in the B2DS scenario, we have no fossil fuels anymore in buildings in 2060, almost nothing, because we think that from a systemic point of view, it's better to put the fossil fuel resource in the power sector combined with CCS rather than in buildings where the efficiency is much lower. So now that we've seen the outlook, we're going to highlight a few energy technology strategies on the envelope performance, on the technology, and the equipment, and how to shift off carbon-intensive building assets. The first thing to notice is that envelope performance is really important to reduce the demand of space heating and space cooling. So in the case of Mexico, it will be space cooling, of course, because this end use will grow at an accelerated rate in the near future. And we see that Mexico is the green on this map. It means that it has no mandatory energy code for the whole building sector, but only for part of the sector. So it is really critical that all buildings are covered by mandatory energy codes for the whole sector, such as in Europe or in China, for example. But we see that it's pretty much the same in the world, and even in India or in other Asia, Southeast Asia, there's going to be a lot of square meters added on the planet, and these additions are not covered by energy codes yet. So here is a little graph to emphasize the needs of energy codes. these are the floor area additions to 2060 in Mexico. So this is what we're going to build. And it takes into account the demolition rate, the reconstruction rate, and the additional buildings that we need because of population growth and because of people need more buildings. So just as a comparison, I put here the total current floor area in 2014. And we see that Mexico will build more than the existing floor area until 2060. Now, another point I want to emphasize is the little window, the window of opportunity that we have. Because by 2035, 50% of those floor area additions will already be completed. So it means that every delay in the actions taken in building code implementation will result in missing all this opportunity. So basically, every action taken after 2035 will only affect half of the building additions. So how do we do to improve the average building performance intensity? First, there are new constructions. So for new constructions, we have near zero energy buildings, and we see that the construction rate of these near zero energy buildings, consuming between 30 and 50 kilowatt hours per square meter, is growing very significantly in the 2DS here. So we need to add one to be more ambitious in terms of the performance after retrofit. So basically, from a current average retrofit performance of 15%, we can go up to 30 or 40% for the worst performing buildings to meet the 2DS and the V2DS. And the net result of all these measures in the building IEA model is a net improvement of 50% of the average building envelope performance. Now, I've already emphasized the need to take urgently the actions, but here's a little graph showing the consequence of a 10-year delay in achieving building envelope objectives in Mexico. So it's just 10 years delaying the actions by 10 years and catching up later. And we see that the contribution, the energy loss, because of this delay, is not very huge on an annual basis. But because building lifetime is very long, we will have this loss on the whole building lifetime, so on maybe 60 or 80 years. So it results in 160 petajoules of heating loss and 785 petajoules of cooling loss. So it's more than 3.5 years of additional energy consumption for heating and cooling. So if you delay the implementation by 10 years, you have 3.5 years of additional consumption to meet. So now that I've finished with the envelope, I will leave the floor to John Dulac for the equipment.
Okay, thank you, Thibault. So Thibault's presented a broad overview of the global objectives as well as some of the critical issues that we see in Mexico, where some of the analysis that we did for ETP 2017 this year was looking at particularly some of the pivotal turning points within the global building sector, as well as you can see in the examples from Mexico with regards to energy technology, priorities, and strategies. Obviously, in countries like Mexico, as well as many of the rapidly emerging economies in Southeast Asia, and even in Africa, cooling demand is in particular one of the critical pieces of energy demand that we see happening in the future. Now, as Thibault mentioned, there is, of course, the critical role for building envelopes, where the average intensity of building envelopes, either through new building construction or through renovation of existing buildings, plays a key role in the total energy consumption demanded for thermal comfort within the building with respect to heating and cooling equipment. Something that we also considered this year with respect to this is how efficient equipment in buildings is. And one of the examples that you see here before you was looking at the net available efficiency of different room air conditioners, so split air conditioners across some of the critical cooling markets globally, and what this means with respect to increased energy demand that we see happening in the future. So if you look across the board here, whether it be developed markets or even developing markets with existing minimum energy performance standards, for example, Mexico, China, the United States, India, or even markets that have lower efficiency potentials with respect to available goods in the market, regardless of the situation, what we see is that in fact globally the average market-weighted performance of split package air conditioners is in fact very similar across the critical cooling markets at roughly a coefficient of performance of about 3. So for those of you who are not familiar with the COP, the coefficient of performance, this is roughly an efficiency of 300%, where you can see here, in fact, that in most of those markets there is a significant window of opportunity with respect to best available performance technologies that are already existing in those markets today, where in some markets we're already seeing performances with COPs above 6, so double the efficiency of what is currently being sold in most markets. So we have a lot of work to do, not only with respect to the building envelope, but in ensuring that we deploy high efficiency technologies with respect to critical growth like cooling in buildings in the near future. A second piece that Thibault mentioned that is new to this year's ETP 2017 analysis is looking at some of the strategies forward with respect to building sector energy consumption and decarbonization, particularly with regards to the Paris Agreement that set new ambitions to go below 2 degrees. So as Thibault mentioned, on your left here you can see our reference technology scenario, where in countries like Mexico we would continue to see a very much continued business as usual pathway, particularly with regards to heating equipment in buildings, which would mean continued use, for example, of oil boilers, some growth in gas boilers, less efficient electric technologies, for example, electric resistance water heaters, and some small deployment of efficient biomass and solar thermal technologies. In a 2-degree scenario, our recommendations for the last 10 years of ETP have been looking at moving towards more efficient, lower carbon technologies, including, of course, technologies like heat pumps for hot water heating and for cooling in buildings, as well as solar thermal technologies to provide better and lower carbon hot water demand in buildings, and that those strategies very much looked at a progressive deployment of clean and energy efficient technologies over the next 40 years. However, within the framework of a below 2 degrees or beyond 2 degrees scenario, as Thibault mentioned, the period in which we would need to decarbonize the building sector is rapidly accelerated from roughly 2100 to somewhere between 2050 and 2060. And as part of that new commitment, there would be a considerable rupture from not only a business as usual perspective, but also from our 2-degree scenario, in which we would see the need to much more rapidly deploy energy efficiency opportunities and low carbon technology opportunities in the building sector, particularly, as Thibault mentioned, in support of decarbonizing upstream power generation. And so what you see here in the right graph, looking at the beyond 2-degree scenario, is in fact what we see as a real opportunity in Mexico to significantly deploy high-performance technologies like heat pumps for heating and cooling demand in buildings, where again we would see a need to significantly increase the improvement of room air conditioners and air conditioning units in Mexico, but also for an end use that is not typically considered within the building framework, which is hot water heating, which is a critical energy demand in Mexico, particularly with regards to traditional use of biomass. And that as part of this clean energy transition, what we would expect would be a significant movement towards high-performance technologies like hot water production using heat pump technologies, and as you can see as well, using solar thermal technologies in our beyond 2-degree scenario. Now, historically, as Thibault mentioned, we have seen some progress with regards to efficient equipment in buildings, where globally, as of 2015 and going into 2016, we saw significant uptake of LED lighting technologies, so light-emitting diodes, with performances that are significantly higher than traditional incandescent halogens and even compact fluorescent lamps that have been deployed in recent years. In Mexico, what we have seen is that there is considerable improvement with the deployment of LED technologies, as you can see here in green in 2015, but that relative to the continued sale of incandescent lamps, which have significantly lower energy performance, and even halogens and CFL, that LEDs are still a significantly small portion of the market, and that in the future we would need to see a significant uptake of those high-performance products to decrease not only the energy consumption in buildings, but the emissions related to upstream power generation for the building sector. If we look forward as part of our beyond 2 degree scenario, what we would see again is a rapid uptake of those technologies, where I want to pause to emphasize that, again, as with cooling equipment, most of the technologies that we are discussing in our ETP scenarios are in fact technologies that are already available and typically cost-effective over the life cycle of the product in most markets. I stop at that point to note that the life cycle of the product, typically speaking, is not what consumers consider within their purchases, particularly within the residential subsector for buildings, where typically upfront costs, so the cost paid for the product at purchase, are those that are considered by consumers. And if we take the example of LED lighting, what we still see as a barrier in this market is that LED lamps are, generally speaking, much more expensive than either their CFL or even halogen and incandescent counterparts, which remains a critical barrier to adoption in the market. That said, the lifetime of LED technologies can be as much as 10 years or more, and so despite the upfront purchase costs that are higher, in fact the return on investment with respect to the significantly higher energy performance of LED technologies is much more improved than it would be with conventional lighting technologies. And so what we would see here would be a real need to push the market, perhaps through a combination of policy tools such as incentives, rebates, minimum energy performance standards, to start driving demand in the building sector for high performance targets, as you can see here on the left, where the top scenario here is in fact what we would see as a rapid and aggressive deployment of those efficient technologies, in this particular case looking at LED lighting technologies for the residential building market. So with that said, we see a significant opportunity, and again I emphasize using technologies that we know are typically available in most markets today, but that we have a pathway to forge in terms of achieving those sustainable building ambitions between now and 2030 and beyond. In this section, we'll discuss some of the energy savings potentials and strategies for achieving those ambitions, and then what this would mean in terms of policy implications in moving markets forward. So first, with respect to what we see as an energy savings potential with regards to energy efficiency deployment in the Mexican building sector, with respect to our reference technology scenario, you can see already here on the left that we see considerable energy savings potential across the major building end uses with respect to improved building envelopes, more efficient heating and cooling equipment, improved and low carbon water heating, lighting and cooking technologies, as well as appliances and other plug loads within the building sector. In a beyond 2 degree scenario, as I mentioned, with a much more aggressive and rapid rollout of energy efficient and low carbon technologies, we would see even larger savings from the building sector, which, as you can see here, lead to a cumulative energy savings of roughly 20 exajoules in the Mexican building sector. I point out, particularly with regards to the previous slide that Thibault noted, that the bulk of this growth, whether it be in the RTS or the Beyond 2DS, is electricity demand across the Mexican building sector, and that we see a real opportunity here to support decarbonization and, in particular, more affordable electricity generation in Mexico by using those energy efficiency opportunities in the building sector. So, how do we get there? In terms of technology strategies and recommendations in the ETP publication, which you can find online if you visit our website at iea.org/ETP2017, we first and foremost start with the recommendation of whole building packages with respect to building envelopes. Part of this, as Thibault mentioned, is looking at high performance envelopes in terms of new construction, as well as deep energy renovations of existing buildings. This can be through combinations of technologies, some of which are advanced technologies, and others which would be more conventional or traditional building practices, particularly in the case of hot climates like Mexico. So to give some examples, this could be the use, for example, of high-performance insulation products for new construction. It could be using double-pane windows with low emissivity films to reduce solar gain in buildings, particularly in hot countries like Mexico. And it could also be using traditional technologies, particularly with respect to the adobe style in Mexico and other parts of Latin America, taking advantage of things like shading on buildings, to reduce the heat gain, and in particular to reduce the amount of cooling demand in buildings. We also at the same time would want to see solutions for equipment in buildings, whether it be heating and cooling, lighting and appliances, or even cooking equipment across the building sector. Starting first again with respect to the building's envelope, we would want to see much more efficient and low carbon deployment technologies with respect to heating and cooling in the building sector. Part of this can be simple solutions, for example, installing better thermal controls and distributions in buildings, which can include not only the heating equipment, but also ventilation, as well as the distribution of heating and cooling in buildings. Some of it, of course, as we mentioned, is using high-performance technologies, such as heat pumps, as well as low-carbon technologies, both for space heating and water heating, using solar thermal technologies. And some of this is also looking at thermal energy storage. So as a quick point here, where we often get questioned as to what we mean, what we see as a real opportunity, particularly in climates that have a real advantage of using solar thermal technologies, is that in fact we could pair solar thermal solutions with traditional storage mechanisms, for example, use of hot water storage tanks, to in fact not only produce low carbon hot water supply, but at the same time to distribute that using thermal storage to reduce the peak demand, particularly again on the power sector, with respect to energy demand for hot water demand, particularly in the residential sector. Some of this may also include the use of district energy solutions, where increasingly we see talks, particularly in the power sector, looking at the issues of distributed energy. What happens as we use more and more renewables in the building sector, and how do we manage it? Because buildings place significant onus on electricity generation, and because we see real opportunities using thermal inertia of the building envelope, using traditional storage mechanisms like hot water storage tanks, for example, and using even advanced district energy solutions like district heating and cooling, we see a real opportunity to use the building sector as a vector for those distributed energy systems to improve overall performance of the energy sector with respect to final energy demand, as well as electricity and the power generation. Finally, with respect to technology strategies for equipment in buildings, we see again a real need to take advantage of existing high-performance technologies like LED lighting and high-performance cooling equipment in the near term, and to ensure that we move markets towards those high-efficiency equipment in the next 5 to 10 years. Now, with respect to appliances, we see significant growth like cooling in Mexican buildings, particularly as household demand for energy-consuming equipment like televisions, refrigerators, dishwashers, washing machines and dryers in some cases, and that we want to make sure that we deploy the most efficient technologies, where typically those are available in your north neighboring country of the United States and even in Canada, but those efficient equipment are often not sold in Mexico. So we want to make sure that we bridge that gap selling those high-efficiency appliances. Finally, looking particularly at the use of traditional biomass in the building sector, we see a need for some effort to move towards clean and affordable cooking solutions, particularly for rural households, where the traditional use of biomass is considerably inefficient, also is paired with local air pollution and health concerns, and that moving first and foremost to improved energy access, and then also to low-cost solutions for rural households, can play a significant role in not only improving the energy demand of the building sector, but also in improving access to energy and the overall quality of energy services for consumers in the building sector. If we were to move forward with this, looking again at what Thibault mentioned for historical perspectives on the decomposition of energy demand in the building sector, we see a real opportunity to rapidly improve the overall energy intensity and demand of the building sector with respect to the reference technology scenario. So again, this is a complicated figure, but to give you a sense of what we're showing here, in the reference technology scenario, we would consider essentially an extension of historical trends where growth in population, buildings floor area, less persons per household, greater consumption of energy consuming equipment, for example, would all drive significant additional growth in energy demand, and that the energy efficiency opportunities that we would not be tapping into would in fact not be enough to offset that considerable growth in energy demand, meaning, as you can see in the diamonds here, that overall energy consumption of energy in Mexican buildings would continue to increase. In a beyond 2 degree scenario, we would still see the same growth in population, floor area, household size, appliance ownership, under the assumption that we would not impact those drivers within the building sector or reduce the energy service provision to buildings. But using energy efficiency opportunities, as we discussed in this webinar, we could significantly reduce the overall growth in building energy demand, thus limiting, in particular, the onus of electricity generation from the building sector energy demand. As Thibault mentioned, this also plays a considerable role with respect to other energy technology ambitions within the energy sector, and in particular electricity growth within the transport sector, with new targets to deploy 30% of new vehicle sales across the world using electric vehicle technologies by 2030. And that, of course, this places significant demand on electricity generation, both in Mexico and in other countries, and that buildings could support this transition. Finally, in terms of emissions, looking again at our objectives of achieving a 2 degree trajectory globally in terms of average annual temperature rise, or of course the new commitments of the Paris Agreement of going beyond 2 degrees, what we see globally here is that energy efficiency opportunities in buildings play a significant role in reducing building-related emissions. To break this down and to explain to you where this is coming from, what you see here in color, including the shaded portions here, going from the RTS in 2060 down to the midpoint of this graph, are in fact energy efficiency improvements coming from better building envelopes, both in terms of new construction and building renovation, in terms of technology performance, as well as in terms of technology choice, again moving towards more efficient and lower carbon energy technologies in the building sector. What's not so evident in this graph is the role that energy efficiency plays relative to upstream power generation. And so what we've provided you with here is information in the hash portion of this graph of what are indirect emissions from the building sector. That is to say, these emissions are not directly produced by buildings. Rather, those emissions are produced upstream from electricity consumption in buildings, and that's what we see, in fact, is that they play a significant role in the total buildings-related emissions reductions to 2060. And that more than 50% of the cumulative CO2 emissions coming from the global building sector, in fact, are due to technology choice and energy efficiency deployment using high-performance technologies and low-carbon technology solutions in the building sector, putting into perspective the real role that energy efficiency deployment in buildings has, not only with respect to building energy performance, but with overall carbon intensity reductions across the energy sector. So with that, some of the policy strategies that we see to conclude in moving forward for the building sector are that we need to move, as Thibault mentioned, to mandatory building energy codes, particularly for new construction in rapidly emerging economies and in regions where we see significant growth in the future, but also for existing buildings, which in many regions continue to be ignored, but that play a significant role in the energy efficiency potential and decarbonization of the building sector moving forward. We also know that we have significant leverage in terms of existing practices, whether they be policy or building construction techniques, that need to be shared across countries. And then in particular, we need to do a better job at capacity building and training to make sure that those that are working in partnership, and especially in local areas, on actual building construction projects or building renovation projects have the right tools at hand and understand the energy technology strategies to improve building envelope intensities. Part of this also means putting forward financing schemes and market incentives to help drive energy efficiency investments in the building sector, where again we know that typically speaking, consumers often make decisions based on upfront costs and not on the long-term return on investment relative to those energy efficiency improvements. As part of such, we see that there's a real need globally to transition to zero carbon buildings, and that as part of this package, particularly with respect to the building envelope, we need a long-term strategic vision for the energy transition. Part of this means setting forward policies that clearly outline the ambitions for the building sector to give long-term vision to the market as to what the expectations will be, not just for tomorrow, but moving forward towards 2030, 2050, 2060, and beyond. Part of this means signaling the market, particularly with respect to the beyond 2 degree scenario, as to what we see as appropriate technologies in the building sector, especially with regard to fossil fuel use in buildings. And part of this means that we need to be more assertive in terms of market frameworks as to what technologies we think are acceptable with respect to available technologies and those that we see coming into markets or having a real need in markets moving forward. In terms of energy efficiency, we know that there's a significant and traditionally a historically very important role of energy performance standards and labeling awareness programs that help to drive energy efficiency investments across all the end uses in the building sector. Again, part of this means putting forward the right financing schemes, whether they be programs like subsidies for initial purchases or rebates for high performance equipment, or even incentives that help pair with those minimum energy performance standards the drive for energy efficiency in the building sector. And that governments, in fact, can play a considerable role and have played a considerable role in the past using schemes like bulk procurement to help to increase the share of those high performance technologies in markets, thereby lowering, typically speaking, the cost of some of those upfront investments. And that finally, in terms of long-term objectives, we see a role for technology innovation. I pause here for a second to re-emphasize that the considerations in the ETB 2017 beyond 2 degree scenario looked at technologies that we see available in markets today, particularly best available technologies, and that what we would see, particularly with a rapid uptake of those technologies in terms of cost reductions, but that we see an opportunity to go beyond those best available technologies through continued support for research and development. In fact, there's a new initiative, Mission Innovation, that has been launched across the G20 Ministerial, looking at opportunities to improve affordable heating and cooling technologies in the building sector, and that we see a real opportunity here to help drive advances in high performance technologies, again, particularly with respect to building envelope measures, heating equipment, and perhaps most critically for Mexico and other rapidly emerging economies, the need for high performance cooling equipment in buildings. So with that, I'd like to thank you all for your attention, and I will hand back over to David, but as a quick note, please remember that we are very happy to answer your questions today, and David will explain to you how you can go about sending questions to us. Thank you.
Thank you very much, John and Thibault. I think we've got now another 10-15 minutes to answer some questions. So again, if people have any questions, please put them in English or Spanish in the question pane, as you see there on your computer. And again, we'll have 10 or 15 minutes. So just allow us to skim through some of the first questions that we've received, and probably I'll start this one with Thibault and then the second one for John. The building sector represents only 7% of global CO2 emissions. So why would it require such a strong focus?
Well, I think this question comes back to the reallocation of emissions resulting from power generation, because the 7% that is usually shown in the graph of CO2 emissions, it's only the direct emissions from the building sector, that is the combustion of oil and coal and gas in boilers, but that does not take into account the emissions from the power sector to produce the electricity that that building assets will consume thereafter. So if we include these emissions from the power sector generation upstream, this 7% goes up to 26%. So suddenly it makes a huge share of total carbon emissions.
So then the second question we have is maybe for John. So what's the role of urban energy system in decarbonizing the building sector?
Okay. Thank you, David. And actually, this is a good question with respect to the webinar we had last year looking at our ETB 2016 analysis that in fact look at the role of cities and urban energy with respect to overall energy scenarios, both again with respect to reference technology scenario as well as the 2-degree trajectory. And then in fact we see as the global population continues to increase in urban areas, and that these will largely be the centers of new demand for energy, that there's a real opportunity, particularly within the building sector, to use these as a catalyst for energy efficiency and low carbon technology investment. First and foremost because these cities typically as the generators of wealth often have the opportunity to invest, particularly with respect to household purchasing power, in more efficient technology. That's not always the case, of course, but that with respect to developing rural areas, we see that there's a considerable opportunity there. And second, that we see some real synergies in urban areas that are perhaps not possible in other parts of the system, some of which I mentioned to you, for example, using district energy systems and distributed energy, that it could help to support decarbonization and energy efficiency improvements in the building sector. The last piece that I might mention with respect to urban energy demand in buildings, particularly in Mexico, is that we see an opportunity here, again because of markets of scale, to use urban centers as the think tanks, if you will, for energy efficiency solutions in buildings, whether they be more traditional building construction mechanisms, for example, or scaling up demand for energy efficient products in buildings to help lower costs and increase awareness of those products in the building sector. And that because of the opportunity of large conglomerations of persons in metropolitan areas, we see that cities, in fact, can play a role both through policies as well as through market frameworks and awareness campaigns to help drive those energy efficiency investments.
Thank you, John. I think the next question I'll ask to Thibault. There's somebody asking, and maybe both of you can answer as well. What do you recommend for new market where the technologies are not available? And I think that touches upon that last slide that you presented about innovation and using standards, etc. So.
No, thanks, David. I think this is probably one of the most critical questions we get in the building sector, looking at, again, coming back to the question of, we say that these technologies are typically available. And as you saw with cooling equipment, the high-performance technologies with respect to, for example, the United States or Japan or even China are not quite as high in Mexico. Part of this is very much due to the different frameworks that drive energy efficiency investments for equipment in buildings, where if demand for products continues to be for less efficient equipment, there's less incentive, of course, for manufacturers to provide higher performance targets in those markets. When we consider energy efficiency policies and the different market frameworks to support energy efficiency deployment, one of the pieces that we critically recommend is a combination of what we call push and pull policies, where first and foremost, again, we would want to send signals to the market, both to consumers and to providers of goods, that we have expectations on high performance energy efficient equipment by driving up those standards over time using minimum energy performance standards. At the same time, we also want to generate market demand for those high performance targets, which helps, of course, to lower the cost through greater market demand, but that also helps to send signals to the market that there's a real demand in the market for those best available technologies. And that providing things, for example, like incentives or subsidies or rebates, for example, for high performance purchases, amongst different marketing tools that can be used with respect to energy efficiency incentives, that we see an opportunity to drive the demand for some of those high performance products, and at the same time to shape markets with respect to what manufacturers are providing in those markets. And I think with respect to Mexico, the critical piece here is that, particularly with respect to your northern neighbors in the United States, most of those products are typically available, and that these combination of push and pull policies can help to ensure that those products are also sold in Mexico.
Thanks, John. We're getting a lot of questions, so we're going to try to answer as many as we can. The next one, which is quite interesting, is do you have analysis that shows the impact of usage of building automation systems on the energy efficiency trends?
Yeah, we recently made an analysis on the impact of digitalization on the global energy system and even specifically on buildings. So historically, digitalization has impacted the building energy system by increasing the energy service provision demand. But most recently, it has taken a decisive turnaround where the energy savings triggered by building automation systems could offset the energy consumed by those systems and even offset the rebound effect stemming from rising demand for comfort and these new energy services. So it will play a very important role, and we already include some of these building automation systems in our 2DS and B2DS scenarios, especially for lighting, heating, and cooling, and especially in the non-residential sector, so the services subsector, because these are places that are easier to be monitored, easier to be controlled, and we exactly know what people are doing inside those buildings, so it's much easier to use automation systems for the non-residential subsector.
Just as one additional comment, and the IEA in fact will be publishing a report on the role of digitalization later this year, so we certainly welcome you all to look at that when it's available online later this autumn. But one of the observations we have made, as Steve mentioned, is that there's a real potential for digitalization to play a role in improving the energy performance of buildings. At the same time, we also see that there is a potential risk if this is not managed appropriately, that in fact connecting devices, which of course has a correlated energy consumption, if we're not going to then use those technologies to better manage energy consumption in buildings, would only add additional demands, particularly for electricity in the building sector, and that there's a real need to ensure that we have the right energy performance standards for connected buildings equipment, and that we use those technologies appropriately.
Thank you, John. Then the next question I'd choose here maybe is in the ETP report, you look at the role of renewable energy integration in the building sector to curb greenhouse gas emissions.
Okay. So this is a very good question, and it's unfortunately a relatively complex answer. Within the building sector, as I mentioned, we do a lot of analysis on final energy demand, which includes solar thermal technologies. Of course, much of the market attention in the last decade has been on solar photovoltaics, so PV, which from an ETP perspective we consider from energy supply, even if it may in fact be produced on buildings. The reason for this is within the broader electricity production framework, we typically count electricity once it goes into the grid, so that is to say it's not directly consumed on site, as part of the overall electricity package, where in fact it's impossible to track where that electricity goes once it goes into the electricity grid. Most PV schemes in the building sector today do in fact contribute to reduced GHG emissions from building electricity consumption. However, we do not account for it in our buildings framework because it is not necessarily directly consumed by the building on which the solar PV is installed. Whereas you're looking at solar thermal technologies, typically speaking, these are consumed on site and very often are replacing either inefficient electric technologies such as instantaneous water heaters, for example, or even electric water heaters that are using storage tanks, which typically have a 10 to 15% loss because of the thermal inertia losses over time. And that solar thermal, in fact, is reducing that energy consumption with respect to either upstream emissions from electricity or from fossil fuels for hot water production. One of the reasons we also place a real emphasis on the potential for solar thermal technologies is because we do see that it has not had enough attention with respect to solar PV, and that particularly for rapidly emerging economies where space heating demand may not be so large, and that includes Mexico, that solar thermal technologies in fact can be a low carbon and energy efficient technology package, again in combination typically with thermal energy storage, to provide hot water needs in buildings that may not have large space heating demand.
Okay, perfect. I think unfortunately we don't have enough time to answer all the questions, but I'd like to thank John and Thibault for their time and for presenting today. So I'll be just closing the webinar. I'd like to thank everybody's attention and participation in today's webinar. Just to recall, this presentation is based on the Energy Technology Perspectives Report 2017 that's been launched and is available on our website, and also there's the information available on some of the data that we've presented here as well on the website. The presentation should be available by the end of this week on the IEA's YouTube website, and we'll be sending you the link as well as the PDF of the presentation. Please feel free to share it with your colleagues. For us, it's been a real pleasure to conduct this webinar, which we hope you found useful. We'd also like to thank SENER and our colleague Anna Lepore, based in Mexico, and for all their support in helping us organize these webinars. We'll continue to organize other energy efficiency webinars, hopefully the next one in September, maybe covering the IEA's energy technology collaboration programs on energy efficiency. We'll keep you informed, and please do not hesitate to contact us if you have any questions. Thank you.
Thank you. Bye.